Today's show is sponsored by Datadog, a monitoring and analytics platform combining metrics, distributed traces, and logs in one place. Datadog helps leading companies migrate to the cloud, transform to a microservices architecture, or transition from .NET to .NET Core. With interactive and drag-and-drop dashboards, see a high-level overview of your .NET applications alongside the health and performance metrics from the application's underlying Azure VMs. Give it a try with a 14-day free trial, and Datadog will send you a free t-shirt. Hello everyone, and welcome to the .NET Core podcast, the only podcast which is devoted to .NET Core, ASP.NET Core, EF Core, SignalR, and not forgetting the .NET Core community itself. I am your host, Jamie Taylor, and this is episode 58, Practical Debugging for .NET Developers with Mikhail Shpilt. In this episode, I talked with Mikhail about the fact that most developers aren't taught a great deal about debugging other than set a breakpoint and inspect values. We also talked about some practical advice that he has for debugging applications regardless of the technology stack used, and we also talk about his new book, Practical Debugging for .NET Developers. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. So first thing I'd like to say, Michael, is thank you ever so much for spending the time with me today to talk about this. Everyone knows, I hope you can hear the bunny quotes there, everyone knows debugging, right? They know that I'll put a breakpoint in and just that's debugging, or I'll do loads of print statements, or I'll create loads of logs that I'll never look at, right? That's how we do debugging, right? But it's interesting to be able to talk to an expert about how we go about from instead of using the tools and like, here's a breakpoint, here's a stopwatch, here's the watch window, how we go from that to actually solving the problem. So I really appreciate you coming on and talking to me about that. Could you first give a little introduction to yourself for the listeners?
Sure. So thanks for having me, Jamie. My name is Michael Shpilt. I've been programming for about 20 years and in the .NET universe for about 10 years now. I work in Oscode, which is a company that's dedicated to debugging for .NET developers. I also maintain a blog, and now I'm in the final stages of my book and video course about debugging.
Excellent. So there's a lot going on there. Like I said earlier on, everybody thinks that they know, well, everybody knows about debugging, and that's, like I said, you put the breakpoint in, you step over, you step in, sorted. Excellent. But I think when I talked to your colleague Omar, we talked about how debugging, like as a platform agnostic technique, as a tool agnostic technique of actually figuring out where the problem is, how to solve the problem, how to put the fix in place, isn't really covered. I went through the university computer science, but that's my background, is computer science at university. And we definitely didn't do anything on actual practical problem solving. So I'm really looking forward to this conversation and reading your book when it comes out, because, you know, as much as I've been doing it for a while, I don't think anyone's really codified how to actually solve a problem or best practices or any kind of tips on how to do that. You know, I'll sit there with a piece of paper and I'll be like, oh, right, I've passed in 3 and it came out 7, but I was actually expecting it to give me a 6. So it's added 1. Okay, so I'll pass in a 4, but now it's giving me 10. But is that the best way to do it? Is that not? Unit tests, maybe. But before we get to the book, I do know that you've been writing over on your blog, Michael's Coding Spot, for a long time, pretty much 4 years now, right? Is that just debugging, or is that all manner of programming stuff? Is it just C#.NET? Is it C++?
It's not just debugging. It's all .NET. I actually started at first with WPF because I had a lot of knowledge about that. But then I quickly moved to C# language. I write a lot about memory, write a lot about performance optimizations, and investigations of performance problems. I write a lot about debugging, actually, lately also.
Okay. So it's a broad range of topics anyway. You know, you're not just the debugging person. You're talking about performance. You're talking about all sorts of other stuff. And I do find that starting a blog on a specific topic as you start to learn more about it, like you said there, you started on WPF, right? So that's a great way to sort of solidify your knowledge and then be able to, because I found I'll solve a problem and then 3 weeks later I'll be sat there going, how did I solve that problem? And I'll go back, and if I've written it down and put a blog post about it, I can go, oh, great, there's this public repository that I've created of these solutions to this problem. And then I don't have to spend the 3 hours figuring out how to do it. I have my step-by-step guide on how to do it, which is how I started writing about stuff. I think it's a good way for people to sort of get into that, is as soon as you solve a problem, write it down, publish it somewhere, even if just put it on a WordPress or a Hugo or something, Blogspot, whatever it is, even if it's just a markdown file in a Git repository. Get it out there, because in 2 weeks' time, you're going to have the same problem and you're going to have forgotten about it, right?
Absolutely. So actually, there are researchers that say when you explain something, then you get it yourself much better. And when you put it in writing for the public, like in a blog post or a YouTube video, then you sort of feel obligated to do the best job and to do the research. And if you don't, then you're going to have nasty comments and bad comments on Reddit, in the blog. So definitely writing a blog is very educational for the writer as well.
Absolutely. It's a great way to sort of learn how to communicate. You've got a paragraph of information, and really you can maybe drop that down to 2 sentences because you've got lots of filler words and stuff. Or, is there a better way to put this? I wrote a blog article back when .NET Core first came out about the ASP.NET Core middleware pipeline, and I drew a really horrendous diagram, just squares with arrows. And then I saw that Andrew Locke had done essentially the same thing, but in a much better way. It was much more detailed. It had like a summary and a conclusion, and the diagrams that he'd created for it were gorgeous. And I'm like, oh, maybe I should have done that. Looking at it from another person's point of view as well, it really helps.
Definitely. Yeah, it's really important to write briefly and concisely. It's an art, I guess. I edit everything that I write about 10 times, and I'm never happy. I can edit it 10 more times. Make everything shorter. Shorter is better. People understand short content. That's my same philosophy with the book. Make things shorter and it will be understood.
Absolutely. And that's a nice little segue. So we've mentioned the book a few times, and you have one coming out called Practical Debugging in .NET. Could you tell us a little bit, what was the decision that went into, I'll write a book on debugging? Is it there are no books on debugging? Was it just because you're an expert? What's the impetus, I guess, behind it?
Expert is a big word. So there are several reasons that went into writing a book about debugging. One of them that I'm working for a company, Oscode, which is dedicated to making debugging better for .NET developers. And we have a lot of knowledge for that, both to try to debug the debugger, to try to debug ourselves. It really presents a lot of challenges. And the other thing is that I wanted to write a book because I was writing a blog for a long time. I really enjoyed it. I thought, hey, why not write a book? That's a decision I live to regret. Don't write a book. But also the topic fascinates me because I think of debugging as solving problems, which is not just placing breakpoints in code. A problem might be a performance issue or a crash or a hang. It can be anything that you need to resolve in software. There are a lot of books about technology, about ASP.NET and WPF, Entity Framework, and so on. There are few books about debugging, but they mostly talk about interactive debugging with Visual Studio and WinDebug. I wanted to write a book about problem solving. So that was sort of the incentive for the book.
Right, I see. It's called Practical Debugging to catch people with the, hey, you can learn how to do the debugging, but it's really practical problem solving. But then if you call it problem solving, people are going to be like, oh, well, I know how to build an ASP.NET website. That's the problem solved. So I totally get why you've called it that. That makes a lot of sense.
Yeah, I actually thought about it. I wasn't sure. I wanted to change it several times, but I ended up with the debugging.
That's fair enough. So you've said there that you want to move away from the interactive debugging, the place the breakpoint, the look at the watch window, the interactive, the actual tools used. So does that mean that the book is tool agnostic? Like, can I take the information that you have in that book and apply it to, say, Rider from JetBrains or Visual Studio Code, or I guess I'm just using Notepad and I've opened the source code. Can I do it that way as well? Or is it, hey, you're going to need this suite of tools to be able to do what I'm doing?
The book is definitely not tool agnostic. I talk a lot about tools, and interactive debugging is certainly part of it. but I also talk about tools for performance and memory profiling and production debugging and solving issues in the cloud, in Azure. And I also have a big chapter about tool agnostic, about strategies for debugging, principles that you can use in any language and any technology, like the divide and conquer principle, where you have an issue and you divide it to two parts, see which part the issue comes from, then keep dividing until you home in. It's both about tools and not about tools.
Okay, so it kind of covers the whole suite. I guess for like a performance thing, you're going to need some kind of tool to log the performance and then to work on the performance, right? You can't just say, yeah, well, what you're going to do is you're going to vaguely do this wizardry over here and it's just going to work. You're going to need some kind of tool to help you, right? So in the Pragmatic Programmer, they talk about how we are crafts people, right? We need the right tools to help us do the job. You need a hammer and a screwdriver and a drill and things like that. It doesn't talk about the brands, but it talks about you need these things in order to go from journeyman to sort of wizard, as it were, in our business. I use the word wizard. I'll have to stop using it. Yeah, you're going to need some tools along the way. But yeah, that totally makes sense because you can't talk about performance debugging or production debugging without actually saying, well, if you use this tool, it's kind of helpful. And these are the steps that you would go through, right?
Yeah, you definitely need tools. Adding stopwatches in your code is not going to cut it. And in .NET, we have a very rich ecosystem we have a lot of tools that can help us. For performance, for example, we have performance counters, which are these overall metrics in Windows that tell you the application health, CPU usage, memory usage, things like that. We have various performance profilers. Visual Studio has an integrated performance profiler, JetBrains, Redgate. We have ETW events, which is a sort of built-in login system, and you can do performance profiling with that, with a tool called Perfew. Lots and lots of very good tools on Windows, and some not so good tools on Linux.
I mean, that makes sense. .NET is kind of not new to Linux because of things like Mono, but like especially .NET Core, or as it will soon be renamed at the time of recording, .NET 5, when they bring Mono and Xamarin and .NET Core together. That whole tool set is new. The whole thing combined together is new. So it makes sense that the debugging tools aren't particularly there. And, we talk about Linux, but it isn't really like... So not the machine that I'm using to record, but my daily driver for all of my development, it runs Pop! OS, which is a distribution of Ubuntu, and it has the Linux kernel, right? So we talk about Linux, but we don't actually mean Linux when we say, yeah, I'm running Linux. Well, you are, but you're running other things on top of it. And because there are so many different distributions, I can imagine that it would be very difficult to write one debugging tool for one language that just works across all of them, right? I know very little about the actual moving parts in distributions, but I can imagine that a distribution based on Debian with the APT package manager versus a distribution that runs on Arch, which has the Yum package manager, there's going to be huge differences there, right? It's almost like Windows and Mac, right? The underlying differences will be so great that it's difficult to build the tools across all of those that will just work.
Yeah, I guess the tool makers, the JetBrains of the world and Microsoft, I guess they have a lot of trouble with that. But now we have some better tools. We have Rider. I know you had a guest some time ago that talked about, that was from the JetBrains Rider team. And so we have a cross-platform .NET IDE now we can debug code on Linux. And also with .NET Core 3, Microsoft added some very needed tools. With the .NET Core 3 SDK, we now finally have good tools for dump files on Linux, for collecting performance snapshot, and for performance counters. We kind of had those tools before in some variations, like we could use the native Linux dump files, which are called core dumps, nothing to do with .NET Core. And we had like sort of an equivalent performance counters, but now Microsoft created tools. They recognize that there's a problem, that if you don't have diagnostic tools and troubleshooting tools, then companies will hesitate to deploy Linux servers. So they fill that gap sort of with those tools. That's a start. And we'll see where it goes.
And that's what we need. We need companies to come forward and go, here's a tool, try and use it. And in some instances, we'll make it open source, and then you can submit any fixes or whatever. And then other companies can then go, oh, cool, I totally see how you've done that. Let me see if we can improve it and make it better, right? Because it's just better for everyone. If someone comes out with something first, and then someone else comes out with a competing product, I mean, that's what the free enterprise is about, right? Competition breeds innovation.
Absolutely. Now, JetBrains has the performance profiling support with .race on Linux. Tomorrow, Ants will do the same, and so on. Absolutely.
Yeah, it all comes down to it being better for us developers, for us tech people, wherever you are in that tech stack, in that company. It is better for you because then you get the information you need.
Yeah, it's all good for the customer in the end. And Microsoft has a huge investment in that, because I think they told, a couple of years ago, that 50% of the servers on Azure is Linux, something like that. And I guess it's more now, because Linux is cheaper and faster. So if they want people to use .NET on Linux, so that they use Azure, and they'll do anything, they'll invest any kind of effort into that, I believe.
Oh, absolutely. I mean, it was just this week at Microsoft Build, right, which dates the recording of this. I think they're still wrapping up at the moment as we record. I'm not sure. It started late Wednesday evening for me, and it was 48 hours. So I'm expecting it to still be going on as we're recording. But the first thing that they showed off was here's Windows Subsystem for Linux 2. Like, Windows now ships with a Linux kernel, and you could just attack that, and it's running Linux on your machine, right? And then they're exposing the actual windowing system, so you can install, say, the GNU image manipulation program on your Linux kernel that is running on Windows, and then call it from the CLI, and it will draw what it should look like on the distribution that you are running inside of Windows, which is just, it's amazing, right? They're exposing that stuff. So then you can see, as a developer, what your app will look like and how your app will behave, because it's got a real, because I think WSL1 was a translation layer. So if you did, I don't know, ls into your WSL terminal, it would translate that to dir, which is ls is list and dir is directory, just to show the files in the directory, right? And it was doing this translation layer. Yeah, they've just sort of bitten the bullet and gone, you know what, let's just ship it with it or enable it or something and just install it on Windows, because then it's easier, because then you've got a real system, and it's amazing. And yeah, if you are going to be shipping your software to run on a specific format, you need to be able to make sure it runs there, right?
It is amazing, yeah, definitely.
So I've talked in the past to your colleague Omar. He was talking to me about a product that Ozcode make that helps with debugging in production. But one of the things that we sort of talked about is that debugging as the problem-solving aspect, not as the here are the tools, here's a breakpoint, here's logging, here's printing to the console, but as a actual topic of the practical aspects of it. We both came to the conclusion that this has been sort of left out of the majority of like training and boot camps and university courses. Do you have any sort of opinions as to why you think this might be? Like, from my point of view, it'd be where I went to university. The university and Microsoft were very friendly. So we got, all of the Microsoft tools for free, the operating systems for free, anything we needed from Microsoft, we got it for free. There may be a little bit of politics involved in that, but we were also doing a lot of .NET. So it kind of makes sense for them to join together. But from your point of view, why do you think debugging is kind of pushed to the side? Is it because we write perfect code every time and it never fails?
That's probably not the reason. Yeah, debugging is definitely pushed to the side. They don't teach that in university, at least not when I learned. But I kind of understand why then they don't teach debugging. And the reason is that beyond the basic functionality of debugging, where you place breakpoints and you investigate variables, you either teach tools or you teach principles. And the tools are very technology specific. For example, in .NET, if you're going to teach debugging, you're going to have to talk about symbols and code optimization and the garbage collector. But then you have JavaScript, which is, you don't have any of those. You have a single thread, so you don't have to do any multi-threading stuff. You run in a sandbox. Those are different things. And Python is a third entity. It's different. So teaching tools is, I'm not sure that's the best for the time. And the principles, well, let's talk about the principles. You have things like, I already mentioned divide and conquer. You can, like there's the principle of do just one thing at a time, where you guess that certain fix will solve the problem. Or say you have 3 fixes. Will you apply all 3 at once, or will you apply one at a time? And in almost all cases, you will want to apply just one at a time, because they might negate each other, or they might cause side effects which you won't know. And these principles are hard to teach when you're just starting out, before you developed the intuition of a software developer with a few years experience. Now, about bootcamps, maybe they should have debugging bootcamps. I think they should have. I don't know if they have them. I never encountered one.
I've never been to a bootcamp, so I don't know what's actually involved. I do know some people who run them and some people who teach at them. I get the feeling that it's like, because you do essentially 8 hours of training to do development every single day. It's kind of, you're expected to go from nothing to graduating in about 3 months to 6 months. From what I've been told, you're guaranteed to get a job at the end of it. What that means, I don't know, right?
I said bootcamps, I meant workshops for experienced developers. Maybe, I don't know if they have workshops for debugging, but I think they should. I think debugging is just a huge part of your time as a developer. You're either solving bugs, which is debugging by definition, or you're developing new features, and then you encounter problems all the time, and then you do debugging.
Definitely, yeah. I can say that around 60% of my time when working on a project is maybe 10-15% of it is design, 5% is writing tests, 2% is writing the code, and the rest is debugging, right? Because throughout your career, you're going to spend more time maintaining and debugging code than actually writing brand new features. Because I joked about it earlier on, but nobody writes perfect code. I've seen live demos with some pretty big names in the business where they messed it all up as they were doing it, because they're doing it live, right? But the same thing will happen when you're working at your workstation or you're working on your open source project or something. You're going to get something wrong. So just accept that and realize that, yes, you are going to spend some time debugging whatever it is that went wrong.
Absolutely. We're not perfect. Nobody writes perfect code. And that's, if you work in a team, which most of us do, that's multiplied, that's exponential. Because you don't know what the other person is doing, or at least you don't know 100%, and you're going to step on each other's toes, you're going to make bugs, and then it's going to be more difficult to debug someone else's code. And you know what? It's going to be difficult to debug your own code after 6 months, a year. I read my own code, I'm sure everybody do. I don't recognize that I was the one who wrote it. Yeah, debugging is a huge part of development.
Absolutely, I completely agree. Maybe there should be training and workshops for developers, and maybe they should not be agnostic. So like, here's a training session for .NET developers on debugging. Here's a training session for Python developers on debugging. Because like you said, with experienced developers, if you are working in a specific language or framework or toolset, you're going to want to be able to be as, you see, a lot of people throw around the word productive. I tend to use the word effective. You want to be as effective with your time rather than productive. Sometimes I found that for some developers, productive just means I've moved this ticket from here to here. It's gone from in development to QA or done or whatever. That's all they care about, is moving that ticket. But you may pick up a ticket that is create a Hello World app, and you may pick up another ticket that is craft an entire microservices architecture that does logging and uses event sources and publish it to Azure and get the user using it. Like, which one of those is more effective for the business? So I tend to use the word effective. But if you are using a specific tool set or framework or whatever, you need to figure out the most effective way to do your job. And if we're spending 50, 60, 70% of our time doing these problem-solving activities where we're looking at code that doesn't necessarily do what it's supposed to do, or rather, there is an edge case in the code and you need to solve the problem of not having that edge case happen, which we call debugging, rightly or wrongly. Maybe we should have training courses where it's like, okay, so first thing, 2 hours on the garbage collector. Here is what that does. Now another hour on here's what async actually does and how you're getting it wrong. Maybe someone should do that. So we've talked about how we can use the tools, the breakpoints, stepping through the code, logging to disk and never reading those logs, analytics, all that kind of stuff, printing to screen. A friend of mine always used to do this. He's a front-end developer. When he has a bug, he actually puts in, like in the JavaScript code, he'll literally, to do his sort of divide and conquer, rather than using debugger statements, he puts alerts everywhere and then slowly starts to remove them until he gets to the line of code that still has the alert. And he's like, that's where the problem is.
I also do that.
And there's nothing wrong with that, yeah. It's a great way of doing it, isn't it?
Yeah.
Then you don't have to have the dev tools open. It's just literally appearing on screen. Alert, alert, alert. Oh, right, cool. That's where it is, right. Remove all of these and rerun. But aside from using the tool-specific stuff, without giving away the content of the book, obviously, right? What are some of the ways that folks can effectively figure out where the problem is and maybe solve the problem?
So I don't mind giving some of the content. There's a lot of content. So yeah, there are a lot of things. That depends. Is if your bug is a logical bug, like your bug can be a crash, right? But let's say it's a logical bug. So if it's a logical bug that reproduces on your development machine, your situation is great. You're in gravy. But it's not always the case. Sometimes it's in production. And placing a breakpoint in production is not always available. It's a problem, because if you stop on a breakpoint, even if you succeed, even if you remotely attach a debugger to the cloud, then your server will stop. It will stop serving requests. And that's not something you can afford. So there are ways to do production debugging. For example, if you have a failed request and it ends with an exception, there are techniques to get the information of what happened without attaching a debugger. One of them is to create a dump file when an exception happens, not when a crash happens, when an exception happens. And then you can get that dump file, copy it to your local development machine, open in Visual Studio, and see the problem. There are other techniques. You mentioned log files. Log files are great. They're very useful for logical bugs. There's also the issue of optimized code versus not optimized code, which is when you debug something in production, then it's usually, almost always, you're going to deploy optimized code because it's faster, right? And debugging optimized code is a problem, because when code is optimized, it inlines methods. And I'm getting a bit technical here, but sometimes breakpoints won't stop and you won't see local variables. So there are ways to restart your process. And even though it was compiled to be optimized, you tell it, don't be optimized, right? And then reproduce the problem and then place breakpoints or whatever.
I think this is where, especially for .NET devs like yourself and like me, learning what the symbols file does. I think that should be, before you learn about the tools and the techniques and how to divide and conquer, symbols files, right? Because I remember at my university course, it was almost entirely done in C#. We did a lot of C++, but the basic stuff that we did, like Programming 101, the very first course we did was, here's C#, here's Notepad, there's the compiler. We didn't even touch Visual Studio for months, right? And then when we did touch Visual Studio, it was like, okay, right, let's talk about symbol files. And they talked about how they work, what they are, what they do. But I feel like a lot of the training doesn't talk about those kind of ancillary, these connected things. Like the symbol files get deployed to your server as well. So then you can get that debug information. But hardly anybody uses them, right? I've worked with many teams and I've gone, okay, right, where's the symbols? What do you mean, where's the symbols? Show me the debug information. What debug information? Ugh.
Yeah, symbol files. Not everybody deploys the symbol files, but even if you do deploy the symbol files, you need the exact source code for the version that it was compiled for. And then if you don't have like a mechanism where you save that information somewhere, and there are technologies for that, I'm not going to get into it, but you can do it automatically. So even if you don't do that, and even if you don't deploy the symbols, there's a way to debug with decompiled code. There are several ways. I'll mention just one, which is there's an amazing tool called Dnspy. It was created by an anonymous user, an open source project, where you can debug a process without symbols. It will show you decompiled code, which is very similar to the original code usually. and you can stop on breakpoints, you can investigate variables, you can do anything. So that's one option to do that.
Absolutely. This episode of the .NET Core podcast is sponsored by ConfigCat.com. ConfigCat is a feature flag service. It has a central dashboard where you toggle your flags visually, hide or expose features in your application without redeploying code, set targeting rules to allow you to control who has access to new features, easily use flags in your code with ConfigCat libraries for .NET and 9 other platforms. Get built out faster, test in production, and do easy rollbacks. Release new features with less risk and release more often. With ConfigCat's simple API and clear documentation, you'll have your initial proof of concept up and running in minutes. Also, train new team members in minutes and don't pay extra for the team size. With the simple UI, even product managers can use it effectively. You could try it out with their free forever plan, or get 50% off of a paid plan with the code NETCORESHOW. That's NETCORESHOW. Release features faster, with less risk, with ConfigCat. Check them out today at configcat.com. We talked about how it's difficult to talk about debugging without talking about the tools, but I think it's worth potentially a course on debugging in .NET, a course on debugging in Python, a course on debugging in JavaScript. All of those courses will be completely different, but they'll have the same practical applications, the techniques, right? But because of the tools, they'll all be different. And I think it's worth noting that if you do want to learn debugging for .NET, debugging for Python, debugging for C, debugging for Go, whatever language it is, whatever tool, React, Angular, whatever, you're going to need to learn the tools, right? You can't just go, I'll put a breakpoint in and that'll be my problem solved. Because like you said, what if it's a performance issue? What if it's only recreatable on the server? What if you've gotten into some weird corner case where it only happens, because this one has happened in the past, I know of this, there's a bug in an old version of OpenOffice. I think it's a version 2 of OpenOffice, where in Writer, which is an application for creating documents, on a Tuesday afternoon on certain systems, you can't print because the printer is just not available. The set of situations that brings it about such a corner case that it was difficult to debug, right? What if in your line of business application, maybe a microservice, maybe a monolith, maybe whatever it is, you've entered into this weird corner case where, it will not work because something is wrong with the framework or the platform or the code or the garbage collector or any of these things, right? So it's totally worth learning the tools to be able to get yourself out of that corner case, because 90% of the time it's going to be, I forgot to, parameterize my SQL. Hopefully you're parameterizing SQL all the time, but maybe it's, I expected my strings to be 4 characters or less. Someone sent in a 5-character string. Right. Okay. So I have to do a check for that. Or sometimes it's the database timed out. It's relatively easy things to solve, but maybe you need a tool to do it.
The tools make our lives easier. Tools are there for us. And the problem is that if you don't know a tool exists, there's a good chance you can still solve the problem with the tools you do have, but it will be less effective. It will take a long time and you will be frustrated. And the problem of you don't know what you don't know is a huge deal in debugging, because debugging is the game of extracting information. If you know, it's not how to fix the bug, it's to find the bug, find the root cause of the problem. And the tools are for that. There are tools that help you get the most information, extract the root cause, and then you can fix the bug.
Absolutely. I mean, you just think about the example that's been playing through my mind is like a crime scene. You don't have an investigator go in or a detective go in and solve the issue. They've got to bring in effectively their tools. They bring in forensics, they bring in ballistics, they bring in experts, they bring in witnesses, and they piece all the information together. So that's what we should do. We should know that the forensics, ballistics. Can you tell I've been reading a lot of crime novels, right? But you bring in all of these things to help you solve the problem, right? And that's essentially what we need to do. We need to learn that these tools exist.
Yeah.
And learn what the framework provides for us out of the box. Because, a lot of people, like we said at the top, and like I've said about 400 times so far, is that debugging to a lot of people is, I'll just put a breakpoint in and just F11, F11, F11. Oh, there's the problem. And that's not always the case. Like you said, what if it's a performance issue?
Yeah.
How would you conduct an investigation into like a performance issue or a memory issue or a crash? Assuming that you've got all the tools you need, and let's say you've written an app and it's running on a Windows environment, right? Just to make it easier, because a large portion of .NET developers are from the Windows ecosystem. How would you go about doing that?
So you know that joke about debugging, how it's a mystery game where you're the detective, the victim, and also the murderer. So how would you conduct an investigation? Okay, so it depends on the problem, of course. If it's a crash, for example, then we have several tools. In Windows, every crash is registered into the Windows event viewer. So you can easily, the easiest thing is to open the event viewer and you see a log of all the crashes and you can see the call stack and the exception message, the exception details that caused the crash. Also, you can configure Windows to create dump files automatically. And dump files is a representation of the process memory at a certain time. And you can open that dump file in Visual Studio, or there are some other programs like WinDebug, but Visual Studio is really the most convenient one. Open that dump file and you can see as if you were running it in Visual Studio, you can see the exact point of the exception and code that caused the crash. Of course, you'll see the code only if you have symbols and source files. Now, performance, we also have some great tools. First, we can use performance counters. Performance counters is a bunch of metrics in Windows that you can find out about any process. You can see like CPU usage and memory and then exception rate and the number of garbage collections, many things. So you can deduct if it's CPU bound or IO bound, like if it was a long network request or if it was a lock contention because you had one thread waiting for another thread because of locks. Or maybe it's a CPU usage. CPU usage is probably going to be the easiest to solve. You don't have to start with that. You can start straight with the big tools, like with the performance profiler. There are several, but like the concept is that you record the snapshot with the performance problem that happens, and then you can see in the performance profilers which took what time, which methods took the longest, what happened in those methods, what kind of code. Was it a network request? Was it a GC pressure? Like a huge amount of problems are happening because of memory, because the garbage collector is not optimized, and a big percentage of the time is taken by garbage collection execution. And you can see that immediately in the performance profiler. It's very easy. And then if it's a CPU problem, then you can see which method caused that problem, and you can even set it up to see which lines of the method caused the issue. And for memory, it's all tools. There's memory profilers, and memory leaks are a huge deal for memory. We have tools for everything.
So then let's change it up, right? We talked about there's a bunch of tools to help you. And we talked about if it's Windows, you can look at the event viewer. But what about if I'm on a Linux environment, right? We talked earlier on about a lot of people are publishing to Linux because maybe it's cheaper or maybe it's more convenient or whatever the reason. Maybe some process requires the ability to use some kind of Linux system, right? Well, if I publish to Linux, I don't have the Windows event viewer anymore, right? And I don't have automatic code dump. So what happens then?
Yeah, so in Linux things, we have less tooling. Things are a bit more difficult. So one option with Linux, if it's in the cloud, is to use commercial APM tools, application performance monitors. They act as a performance profiler, but also they show things like crashes and request failures and a bunch of stuff. That's sort of the easy way out, but it costs a lot of money, and also there's the performance overhead. Now, suppose you don't want to use an APM and you want to find out about crashes. One way, Linux does have dump files, so you can use sort of the Linux native dump files, but that's going to be a bit difficult, because then you'll have to debug them with Linux's native debugger, command line debugger, which is equivalent to WinDebug. Some of the listeners probably remember it. It's a command line. So Linux has an equivalent to that with its own command. So for a .NET developer, it means they'll have to learn a new technology. But as of .NET Core 3, there's a tool called .NET Dump, if I'm not mistaken, in the .NET Core 3 SDK. And then you can attach the process and it will create dump files. And then you can debug it on Linux with the same interface like WinDebug. So you'll know the commands and you'll have all the stuff for managed code, which is something .NET developers are used to. Yeah, in case of a performance issue on Linux, .NET Core 3 SDK also has a tool called .NET Collect, where you can record a snapshot, copy it to a Windows machine, open with Purview, which is an open source performance profiler, also by Microsoft, by Vance Morrison, which is one of the chief architects in there. It's not easy. It's not an easy tool, but it gets the job done. It's very powerful. And in case of memory is still, memory profiling is still a problem on Linux. I hope some of the, like JetBrains, I hope they support .memory on Linux soon. There isn't a solution yet.
So there's a number of tools, and we're ripe for innovation, right? There's a number of tools that require you to learn another system more. Maybe you could bring in a Linux expert and say, look, my app has died. I've got this dump file. Can you have a look and just debug it? Or like you said, pull it over to Windows and do it that way. Either way, you're going to have to learn a debugging tool, the WinDebug or the Linux equivalents, right? You're going to have to learn to read these core dumps, I guess. So that makes sense. So we've talked about Windows, we've talked about Linux, that's fine. But what about if it's in production? Because usually, like you said earlier on, you deploy to production and perhaps your code has already been optimized. So one of the big things in, I think, .NET Core 3 is that your code gets rejitted each time around. So then essentially it can be re-optimized and re-optimized and re-optimized. So you may have had 15 requests go through, only 3 of them succeeded because every time through it's rejitted it and changed the code. And then what about, we live in a world that uses, I'm playing a lot of buzzword bingo today. We live in a world of continuous deployment, right? Keep pushing all the changes to production constantly because we're apparently Netflix and we want to use that route. Well, what if the version on production is 5 steps behind your local dev, or maybe 20 steps behind your local dev, and you can't debug because the source code has changed? Not just on the server because it's been rejitted, just in time compiled, but it's also the source code that was dumped there is 15 steps behind what the source code on your machine is.
Yeah.
Right? How in the heck do you do that?
So there are a couple of technologies where you can automatically, in the symbol files, save a link to the source code exec commit. And this way, Visual Studio supports this. When you open, say, a dump file, then in the symbol file, it will automatically pull that source code from Git or from CFS, CFVC, or whatever, and it will connect them. It will match the symbols and source files, and it will work. But that's just part of the problem. You mentioned optimization. That doesn't solve the optimization. Also, it's a solution that you're going to have to make a lot of effort to implement. It's not that easy. You have to set it up. You have to set up it in Azure DevOps or whatever pipeline that you're using. It's not that easy. Now, the code optimization, it means that when you do debug, whether you attach to the process or when you open a dump file, some local variables won't be seen, and the call stacks will be partial because code optimization also inlines methods. It makes one method be part of its parent method. So one way is not to deal with that, is to get partial information, and maybe that's enough. Another way is that you can tell the JIT compiler, don't optimize in runtime. And then you restart the process. It's not going to be optimized. It's going to be a bit slower, but then you can debug and find the information. Another way, which about the symbols, is don't bother with everything with the don't bother with the symbols. Is to use Dnspy or .pick. With .pick is a decompiler by JetBrains that can act as a symbol server with decompiled code. What that means is that you can attach to a process that, without source code on symbols, see the decompiled code, stop on breakpoints, and so on. So maybe don't bother.
The more that we've discussed this, it seems that deploying code with the ability to debug it requires a lot more than just push it to the server and hope for the best. Which, to be fair, a number of people that I've worked alongside of in the past have done that. They're just like, I push it to the server, we'll get an error report, and we'll be able to figure it out. Don't worry about it.
Well, that's one way to approach things. But yeah, then it's not so easy. That's why if it was easy, there was no need to write a book about it. There are a lot of subtleties.
Okay, so we've got framework and we've got core, and obviously mono and all the other platforms and stuff, but are there differences in how to do debugging in framework and debugging in core? Now, obviously, it's the same tools you may be using. You may be still using Visual Studio, you may be still using Rider, you may be still be using dump files and stuff. But what are the differences? Or is there a difference between debugging framework and debugging core?
Yeah. So under the hood, it's a different debugging engine. But Visual Studio, when you attach to a process or open a dump file, it automatically recognizes if it's .NET Core or .NET Framework, and it uses the right debugging engine. In almost all cases, you don't have to worry. In some edge cases, you do have to know this, and you're going to have to tell Visual Studio when attaching, use this debugging engine. Most tools on Windows do support both .NET Core and .NET Framework, like the various profilers and the debuggers, WinDebug, and all those tools. Everything is supported for .NET Core as well.
So from a user interacting with Visual Studio, there's no real difference. It just does the things behind the scenes to actually allow you to continue your journey.
Yeah, they're seamless, completely seamless.
Let's say I've got my app ready, I've got my system ready, I go, right, deploy to Azure or deploy to AWS or deploy to, I don't know, Steven's code system on cloud or whatever. I deploy to some cloud deployment system because I want my app to be infinitely scalable and always on and all of these wonderful things. And then a crash happens. And I'm like, if it's on-prem, I can go onto the server, I can remote to the server and do what I need to do and get the files out, but it's on some other system and I can't get access to it. What do I do then?
So if it's a virtual machine, maybe you can remote desktop to that machine. And it's not always a virtual machine, but if it's a virtual machine, you can remote desktop and then you can open Windows Event Viewer and see the call stack of the exception. Or you can set it up to create dump files. Then you can copy it to your development machine, open the dump file, and investigate. If it's in Azure App Service, then you can't remote to that. You have a command line access. In that case, there are many tools where in command line, you can create dump files automatically when a crash happens. One of those tools is ProgDump. It's part of the sys internal suite. It's already pre-installed on any Azure App Service. And you can tell ProgDump to attach to that process, monitor it. When a crash happens, generate a dump, copy it to your development machine, open in Visual Studio, and investigate.
So there's a command line app that's always running that you can say, get that thing and tell me if something goes wrong. Now, we talk about dev and we talk about ops and we say how that everyone should be like DevOps. Everyone should have access to what they need to get. Only a very small team of people should have access to the live server, right? I shouldn't, as a developer, be able to access a live system that I shouldn't have access to. So what happens if I'm one of the many people who don't have access to that server? I can't get permission to get ProgDump running. What happens then?
So in that case, you can use Oscode. Oscode, it has a feature of personally identifier information. It redacts private information and sensitive information. And when a crash happens, you'll be able to see in a sort of ID in the browser the code without a credit card and stuff like that. But that's a problem because the dump file it contains sensitive information and not everybody should be allowed to access to it.
Absolutely. Okay. That was my main worry, right? You take a dump of the memory for that process, right? Let's say you're dealing with credit card transactions and for some reason you have a customer's name, address, social security number, credit card number, orders, how much they've spent on this, what they're actually buying. That's really confidential information.
Yeah. It's going to be in memory and the dump will contain that information.
Exactly right, and there's all sorts of new laws coming into place now. We talk about GDPR. We talk about there's one for California I keep forgetting the name of, and each jurisdiction, each country will have its own privacy and data laws. So taking that dump of information of someone's real transaction in process and just it's fine. I'll just put it on my computer and I'll look through it. That's a big problem.
Yeah, it's a huge problem.
So then things like the stuff that Oscode does, I think Datadog do something similar, but let's say tool agnostic, right?
Mm-hmm.
You need to have some tool that sits there and watches the code and gets that memory dump. And you mentioned that Oscode make a tool that will do that and then scrub the personally identifiable information. Okay, so I've done that. I've now got a code dump, or I can then put that into Visual Studio and just go, oh, right, yeah, I can see that. And then I can apply the techniques, right, that you talk about in the book.
Yeah, so with Oscode, it's not, you don't actually get the dump file. Oscode saves that from you. Instead, you see, say there was a crash or an exception, you can see in the browser an IDE like Visual Studio, but in the browser, where you can see the code, you can see the call stack that led to the exception, and the personal information will be scrubbed. Yeah, then you look at that. Hopefully, the personal information is not needed to solve the problem. You try to figure out, okay, there was a divide by zero exception. There you go. Yeah, in some cases, with OSCode or with a dump file, you can take, suppose there was a request where it eventually caused to an exception, and it's something that reproduces just in production. In which case you can take the payload that led the request, place it in your local environment, in your development machine, and try to reproduce locally. That's a good technique to solve bugs.
That makes sense, because if it's the input that's causing the issue, you need that input.
Yeah.
My silly example from earlier on, I have a method, I pass 3 into it, I get 5, I pass 4 into it, I get 10. I need to know why it's getting into that state. Well, maybe it's the data coming in, right? Or maybe once the data's come in, it's doing some transformation on it and then it's passing it on. Without having that data, I won't know whether the transformation is correct or not. Whether or not we do test-driven development or not, we talk about having unit tests, integration tests, full suite of tests. But who tests the tests? Who ensures that the tests cover enough of the system and enough input data and enough stuff to guarantee that it always works? No one can, right? We talked earlier on about we write buggy code as developers. It doesn't matter where you are in your career, you're going to write buggy code. If that's true, then it must then follow that you potentially write buggy tests, right? So you can't always rely on the tests. You have to rely on the actual state of play in production to actually give you information about what went wrong. Yes, you can use that information to then create a test which tests if I give the system bad data, does it crash or does it heal itself or does it log something, raise an exception and tell the user, you've been a wally, you've given me the wrong data. But without that information, you can't build the test to ensure that it doesn't fail again.
Yeah, tests are not a magic solution to all your problems. You're going to keep having bugs, probably. You need to test correctly, and you're probably not going to cover all the cases, and you're definitely not going to cover the scale and that you get in production. And also, if you have tests and they fail, for example, just in the build server, that's a whole new problem that you need to debug the tests that fail in the build server. So it introduces new problems as well.
Absolutely. And I think that, for instance, I'm going to play buzzword bingo one more time. If you're moving from a monolith to 100,000 microservices, that's going to be a pain to debug because in the past you've had one lump of code on one server in one process that you can debug easily. But if you've got service A calls service B calls service C calls service D and service C fails, what happens? that becomes harder to debug. And I think that just relying on tests and logging, and I talk about logging, but let's just pretend that logging doesn't exist, right? Because A, you never log enough data. And B, when you have logged enough data, you're never going to look at it. And C, all that does is it slows the server down because there's 100 million gigabytes of logs that you never look at.
Yeah, definitely. Logs is always a problem because when you do need them, just the exact log that you wanted isn't there. Then you need to add logs, deploy again, wait for the bug to happen again, get the right logs and see. And microservices is a huge problem to debug. Microservices has a lot of downsides, and one of the downsides is the ability to debug. It's harder. So you can give like a correlation ID to a request, and whenever it moves between microservices, it's going to have the same correlation ID. Then when you investigate those logs, you will look for that correlation ID, get the output from all the services. And actually, OSCode, what we're doing is when there's a problem in a request, when it failed or when we place a breakpoint, we track all the microservices that the request passed through, and we will show you the path of between microservices with the payloads and the entire information. Without OSCode, you're going to have to rely on logs, and it has its problems.
Then you throw into the mix async.
Yeah.
You've got an async event queue, and then everything goes completely wobbly because, well, what if the event queue dies? Or what if it feels very much like my own personal experience, right? So this is personal experience of me, Jamie, the person. I've seen microservices implemented wonderfully. There's redundancy, there's logging. The problem is that your 3-line microservice then becomes 25, 50, 100, 150 lines just because it's got all of this redundancy in case something falls over. And then I've seen microservices where it's just been, just throw it out there and see what happens. We'll throw all the code at the wall and see what happens. You've got a 3-line microservice talking to a 3-line microservice, talking to one event queue that then dies and you lose 100,000 transactions and your business goes under, right? So it's finding that happy balance between the two is almost impossible. And I think maybe the future is installing tools like Ozcode or Datadog or whatever, all these hundreds of tools that help you figure out what's going on. Because I kind of joked at it earlier on where I said, we're clearly as big as Netflix. We'll just throw everything at the cloud and see what happens. And the problem with that is, of course, you aren't Netflix. You don't have 100 million customers. You don't have 100,000 servers. You have one server. You have 3 customers. And that's it. Plan to scale out, definitely, but don't start with we have to scale to 1 million servers because it's going to take you years to get there.
Yeah, don't do any premature optimization.
Exactly. Who was it that said? I think that was that Dijkstra?
Donald Knuth.
That's right. Yeah, Donald Knuth. The premature optimization is the root of all evil. Yeah. That's it. So the book then, Practical Debugging in .NET.
Practical debugging for .NET developers.
Sorry, yeah, for .NET developers, that's it. What's the target audience? Are you aiming to teach debugging as a here are tools, this is a process, or is it more a case of give us an introduction to the book?
Sure. The target audience, I'd say it's intermediate and experienced developers. So in the book, there's sort of 3 parts to it, to teaching how to debug. One part of it is the tools. I show the tools. I explain what information these tools can give you. The second part is we go from, instead of focusing on the tools, we focus on the problem types. And then say we have a memory problem. So I explain what kind of problem do we have? What's the investigation process when dealing with that problem? Which tools should you have? And then the final part is common patterns that lead to problems and common solutions. Because in most cases, not all cases, but in most cases, you're going to have like the 80% of problems will be similar, will be of common patterns. Common patterns, there are common ways to recognize those issues and also proven fixes for those problems. So, and the book, it explains all of those. I also decided somewhere in the start of the book to create video lessons as well, because some of the tools are not very easy. They're okay if you know a little about the tool, and then I explain it in the book, kind of understand the missing pieces. But if you don't know the tool at all, unless you install it and try it, screenshots and the book is not enough. So I decided also to do video lessons. And there are about 5 hours of video lessons accompanying the book. Yeah, so that's about it.
It's difficult to describe either in words or in audio how a visual system is put together, right? So, rather than saying, well, go to File and then New and then type this thing in, or go to this tool menu and click that button, and what if the user interface changes? In audio, that's a huge problem. In video, you can kind of go, well, this is where it is in this version, and later versions may change. We don't know. But at least then you can see roughly where on the screen those tools used to be, which then means you can search for them or you can look at the change logs or whatever. I could appreciate that as a developer, having some kind of video to fall back on as well. I've read the book, I get the point, I get the information, but now I want to see it in actual use because it's easier to see them in use, right? That's why Pluralsight is huge. That's why Udemy is huge. Well, that's why live coding is huge. That's why YouTube has a whole bunch of video tutorials on how to do stuff, because it's easier to be walked through the user interface. Click this button, or type this command in. Even if it's a command line system, type this command in and you can see it happening, right? It's like it's animated videos of how the process works are easier to follow than read this paragraph, now read this paragraph, now read this paragraph, right? Because eventually you're going to stop reading.
Yeah, that's how people learn today. People learn a lot from videos. And the book also has a lot of advantages, because in the book you can, it's a reference, right? If you forget something, go to that book. You don't need to see the video all the way from the start and then stop it right the right minute. Also, you can skim through stuff that you already know in a book. And but I think a lot of more effort goes into a book, because you sort of work on each sentence and on each word, and I think the quality of books is higher than that of videos, almost by definition. Yeah, so books aren't replaced yet, in my opinion, by videos.
So we're recording this a little ahead of time, and there's still some effort required to sort of to finalize the book. There's still a few stages left. And I think we were talking off air. I think you'd said you don't know quite where it's going to be published yet. I think you said it was going to be self-published. I'm just thinking, where can folks find out more about it when it does come out? Is there a plan for that yet, or is it still in the planning stages?
Yeah, so it's going to be published on Amazon, but also I have a website, practicaldebugging.net, where you can get an ebook and the videos, and the printed version is on Amazon.
Okay, excellent. So when you're listening, check the show notes in your podcatcher player or click through to the full website. I always put a transcription up there as well. So if there's a part where I've fumbled through and you're not quite following what I'm saying, scroll through and you can what's great about that is if you want a quote or something, it's right there, right? You can Control F and search through text. You can't do that through audio, right? So make sure you go through to the show notes, because when I put this together, I'll reach out to Michael again and get a bunch of links to maybe on Amazon and maybe the ebook page and stuff like that. All of the information that you're going to need will be in the show notes. So definitely check through to those. So what about catching up with yourself then, Michael? What's the best way to do that? Is Twitter a thing, or is it more a case of just checking the blog? What's the process for that?
I'm mostly active on the blog. You can also catch me on Twitter at Michael Shpilt.
Excellent. So we'll make sure to drive people towards the website so they can check that out. Because honest opinion, I want to learn more about debugging. I know a little bit about symbols, and I know that a lot of people that I've worked with in the past, I don't know whether it's coincidence or not, they don't really get debugging. It's just a case of, well, I still hear it today. Well, it works on my machine. That's not the point. It's broken in production. Go fix it. Yeah, but it works here. I don't care. It should not be, it works here, so I stop working. It should be, it works here, but it doesn't work there. That's a huge problem. That should be your first step.
Yeah, responsibility. You are responsible for your code, and it works on my machine is not an excuse.
Exactly right. It shouldn't be, because, like I said, if it works on your machine but it doesn't work in production, then that's a huge problem, because there's some kind of disconnect. Or if it works on your machine, doesn't work in QA, but it works on production, we'll skip over how it got to production after QA failed it. But if it works on your machine, fails at QA, but works in production, then there's something in the middle that needs to change. I can see why this is one of the reasons why people use containerization, Docker, Kubernetes, whatever, because then you don't have to have it works on my machine, it doesn't work over here, because your entire development, test, user acceptance, whatever you call these stages, each of those stages is running the exact same operating system, the same tools, the same everything.
Yeah. As professional software developers, we should have a code of ethics or something, like Uncle Bob Martin talks about this, where we should be responsible for the code we write.
Exactly. And it should be a case of, if there's a problem with the code, we should all come together and go, right, okay, how can I help? Is there a way for me to help? If it's code that someone else has written, well, it's not necessarily their code, it's the team's code, right? So the team needs to get together and say, right, what can we do to fix this? How can I help? Is there anything I can do? Or should I just leave you to it? Or, what's the problem?
Yeah, definitely.
Thank you for having to chat with me today, Michael. I'm eagerly awaiting the book, I have to say. And I'll make sure that there's a link for people to click through to check the book out, because I think it's going to be an interesting read. And like I say, I think there's a definite gap in the skills. Maybe you can start doing courses on how to debug in .NET. What is a symbol file? What is this? How does this work? Maybe I'm just making work for you.
Thanks for having me, Jamie. I had a lot of fun.
No worries. Thank you ever so much. That was my interview with Mikhail Shpilt about debugging. Be sure to check the show notes for a bunch of links to some of the stuff we covered and a full transcription of the interview. The show notes, as always, can be found at .NETcore.show, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave me a rating or review on your podcatcher of choice. Head over to .NETcore.show/subscribe for ways to do that, and to come back next time for more .NET Core goodness. I'll see you again real soon. See you later, folks. .NET Core Podcast is a production of RJJ Software Limited.